TED regulations have been revised to improve the exclusion rates of larger sea turtles. The new regulations require enlarged escape openings on all TEDs. There are 2 enlarged TED openings which are allowed in the offshore waters of the Gulf of Mexico and South Atlantic, and inshore waters of Georgia and South Carolina. These openings are the double cover opening and the 71-inch TED opening. This video will demonstrate how to modify your existing TED to meet the requirements of the 71-inch TED opening. The 71-inch TED opening is a modification which is easily accomplished by enlarging the existing escape hole cut and installing a larger flap. These modifications have been tested for turtle exclusion and shrimp retention by the National Marine Fisheries Service Pascagoula, Mississippi Laboratory aboard commercial shrimp trawlers. In this video, we will use mesh counts for a particular mesh size. These mesh counts will differ depending on the size of webbing that you are using. The regulatory requirements are based on inches and not on mesh counts. All measurements provided in this video are a stretched mesh measurement. It is the responsibility of owners and vessel operators to be sure that measurements are in compliance with the existing regulations. The first step is to remove the existing exit hole flap and determine the size of the existing escape hole cut. The escape hole cut is a rectangular cut in the extension which will be covered by the flap. The 71-inch TED requires an escape hole cut of 71 inches across the leading edge and 26 inches along each side. Remember, these are stretched mesh measurements. If the existing escape hole cut does not meet these measurements, the cut must be enlarged to meet this requirement. You may want to use a calculator to determine this. To determine the number of meshes required for the forward edge, divide 71 by the stretched mesh size of the webbing that you are working with. Because webbing sometimes shrinks from repetitive dipping or may be slightly off-sized, the result will be an approximate number of meshes. Before cutting, you should double check by measuring. In this case, the old forward edge cut is 41 meshes and the side cut is 16 meshes. If the mesh size is 1 5/8 inch as shown here, the forward edge cut should be approximately 45 meshes across. This cut would need to be enlarged by 4 meshes. The 4 meshes on the leading edge will be divided into 2 meshes on each side. For 1 5/8 inch webbing, the side cut should be approximately 19 meshes. So from the TED frame, make a 19 mesh cut while maintaining the 45 mesh cut across the leading edge. As mentioned before, the mesh count will be determined by the mesh size that you are using in your trawl. After the exit hole is increased to the required size, a larger flap must be installed over the opening. The regulations specify that the TED flap must be made from webbing with a mesh size no larger than 1 5/8 inch. The flap must have a minimum stretched measurement of 58 inches long by 133 inches wide. Again, you may want to calculate the number of meshes needed to obtain this flap size. For 1 1/2 inch webbing, the new flap will need to be approximately 88 meshes wide by 39 meshes long to meet the minimum requirements. It is suggested that the flap be made from heat set and depth stretch polyethylene. This material will stretch out and return to its original shape better than materials such as nylon. It is also recommended that the flap not be dipped. Dipping the flap will cause it to lose its elasticity. Additionally, the flap should be installed with the knots oriented correctly in order to maintain a better fit on the grid while fishing. Here we get a close-up look at the knots of larger mesh webbing for demonstrational purposes. If we imagine the webbing being pulled through the water such that the water flow is from right to left, then you can see the angle in which the knot is contacting the water. This will cause a downward force on the webbing. This knot orientation would be advantageous for a flap on a top exiting TED. The opposite knot orientation would be advantageous on a bottom exiting TED, as seen here. Information on how knot orientation affects the performance of webbing can be obtained from the Harvesting Systems Division of the National Marine Fisheries Service in Pascagoula, Mississippi. The 133-inch edge of the flap will be attached to the 71-inch forward edge of the escape hole cut. Begin by counting the meshes across the leading edge of the new escape hole. Find the center mesh and mark with a piece of twine. Now find the center mesh of the flap and, starting from the center, attach the flap to the leading edge of the escape hole. Attach the flap evenly along the leading edge of the escape hole, working from the center outward to each side, taking up meshes as needed. The cover should overlap no more than 5 inches of the exit hole on each side. This will probably be about 2 to 3 stretched meshes. Now sew the sides of the flap to the sides of the escape hole while maintaining the 5-inch overlap. Sew down the sides of the opening by sewing 28 inches of the cover to 26 inches of the opening forward of the TED frame. Continue sewing down the sides beyond the grid. Repeat this for the opposite side. TED regulations allow the flap to be attached along the side of the extension to a point 6 inches beyond the posterior edge of the grid. From the bottom of the grid, measure down 6 inches and follow that row of meshes over to where the edge of the flap is being sewn. The flap cannot be sewn past this row of meshes. With the sides sewn down, now make sure the trailing end of the flap does not exceed 24 inches from the posterior edge of the grid. This measurement should be taken as it hangs and is not a stretched measurement. Once the installation is complete, check to ensure that the opening will meet the new 71-inch stretched requirements as shown here. If you are using a funnel in your TED, the tapered end of the funnel should be able to stretch to 71 inches or measure 142 inches in circumference. The divers from the Harvesting Systems Division use a model of a leatherback sea turtle to see if it is possible for an object of this size to pass through. As you can see, the turtle simulator passes through the flap. Additionally, there is companion literature for this video, and it along with additional technical advice can be obtained from the Harvesting Systems and Engineering Division of the National Marine Fisheries Service in Pascagoula, Mississippi at the following address: